Hello and welcome to revision classes on television. Today, we will be having a session in mathematics. Our guide is Rafiat Yusuf, and our topic today is logarithm.
Remember that we are reviewing WAEC past questions from 2015 all through to 2019. So we'll be treating some questions related to logarithm from the past questions. But before we go into that, what is logarithm? We know that there are some laws guiding this logarithm. Laws like the multiplication rule, the division rule, the power rule, and so on and so forth. Having that in mind, let's go through some of these questions while we apply those laws in them. Question number 1. We have, given that log 64 base x is equals to 3, evaluate x log 8 base 2. Now, looking at this question, you see that they gave us this value. We need to first evaluate this value before we can do this. It is this that will give us the guide to solving this question. So, solution. I also like to remind us that there's a relationship between logarithm and indices, where you have logarithmic for a function being changed to exponential function. Looking at this question, we have log 64 is equals to 3. The log is in base x. We can change this logarithm to become an exponential function. That is, the base of our log will come here. We have 64 equals x raised to power of 3. You see it from this log now, it has been changed to exponential function. Now, having this, we know that 64 can be 4 raised to power of 3. 4 raised to power 3 is same thing as 64, which is equals to x raised to power of 3. Now, since our index are the same, I mean your powers, since they are the same, you can equate your bases. Just as when we have the same base, we equate our powers. The same rule applies when your index are the same, you can equate your bases. So since the index are the same, you just say equate your base as x. 4 is equals to x. Another way of solving this, from here, you can as well say x raised to power of 3, which is equals to 64. This x is what we are looking for. So, and we have a power attached to that x. How do we eliminate this power? We know that this is cube. So to get this cube eliminated, you take cube root of both sides. So taking cube root of both sides, cube root of this other 64, the cube root, we cancel this cube. Now we have our x to be, what is cube root of 64? That's that number that multiplied 3 times, it will give you 64. That number will be 4. You see, at the end, we still have x is equals to 4. Now, we have that our x is equals to 4. We are not finally at the answer because this asks us to evaluate this x log 8 base 2. Now, we have the value of x. We can as well use it to solve this. So, having x log 8 base 2, we can simplify this, our log 8, to be in base of 2. That is x log 8 is 2 raised to power of 3 base 2. But we know that our x is equals to 4. So we substitute the value of x to be 4 now. That is x log 2 raised to power of 3 base 2. Remember that part of the laws of logarithm, when you have the power comes down to multiply the log. So this power here, we can bring it down to multiply the log. Bringing the power down, we have 3 times 4 log 2 base 2. 3 times 4 will give you 12 log 2 base 2. Another rule of logarithm is when you have a log to its base, when the base and the log are the same, it gives 1. That is, if I have log a base a, it equals to 1. So if I have log of any number to the same base, it equals to 1. So such rule, we have it here that log 2 base 2 will also give you 1. So we have 12 This is now 1 because log 2 base 2 is 1. 12 times 1. Finally, 12 times 1 is what? 12. So our answer is 12. We have evaluated this log. So question number 2, we have if open bracket y minus 1 close bracket log 4 base 10 is equals to y log 16 base 10, find the value of y. Okay, looking at this question, remember I told you that when you have a power in logarithm, the power will be brought down to multiply the log. If you look at this question, we can simply say that this y minus 1 was brought down from the power of this 4. So we can as well put them back to their previous position. Solution. Having this log, y minus 1 log 4 base 10 equals y log 16 base 10. Like I said, we can put this y minus 1 back to the power where it previously was, and this y we can put it back to the power to become 16 raised to power of y. So we have log 4 y minus 1, don't forget your base is 10. We have log 16 base 10, putting the power back. We haven't committed any crime. This is the same thing as this, because if you apply that rule of the power law, we have the power being brought down to multiply the log. So from here, we know that this log 10 and this log 10, they are the same. We can cancel out. When you cancel out, we have 4 raised to power y minus 1 equals to 16 raised to power of y. Now, how can we make this to be in the same base? I mean the 4 and the 16 to be in the same base. We know that we can simplify this 16 to be in base 4. 4 raised to power 2 will give you 16. So doing that, we have 4 raised to power y minus 1. This is now 4 raised to power 2, which is replacing our 16. Don't forget that we still have a y there. Put it in bracket y. And like I said, anytime you have a bracket, we always open up your bracket before you proceed. So we have 4 raised to power y minus 1, which is equals to 4 raised to power 2 times y, we give 2y. Now that they are both in the same base, you know, we cancel out the base. As if your bases are the same, you equate your powers. So equating our powers, we have y minus 1 equals to 2y. Collecting like terms from here, I can have my y, bringing 2y to the other side, minus 2y equals, taking minus 1 to the other side will give plus 1. So what is y minus 2y? It will give you minus y is equals to 1. We cannot leave our answer like this because this minus sign is still with our y. So you can just say multiply both sides by minus. If you multiply both sides by minus, this minus, we cancel this minus here. So you have your y on its own now. When you have minus times 1, we give minus 1. So finally, the value of y is minus 1. question number 3. We have if log base 10 6x minus 4 minus log 2 base 10 equals 1. This is 2, please. Solve for x. We have log 6x minus 4 minus log 2 equals to 1. How do we solve this? One of the rules of logarithm where we have the division rule. The division rule is when you have, let's take for instance, you have log p over log p over q. You can simplify it as log p minus log q. So when you have a division, you subtract your logarithm. And when it is multiplication, you add the logarithm. We have log 6x minus 4 base 10 minus log 2 base 10 equals 1. So I said from here, we know that when you have subtraction of logarithm, it's taken from the division. You have log p over q will give you log p minus log q. So we can as well evaluate this by putting it with division law. That's log base 10. We have 6x minus 4 all over the value of 2 here equals 1. This was simplified like this. So from here, we know that this one, we want this one to also be in the same logarithm with this. This is in log base 10. So one of the rules of logarithm is, like I said in our previous class, we have log to any base. If the base and the log are the same, it equals to 1. So I can as well use log 10 base 10 to replace this one in this case so that the logarithm will be the same. So replacing this one with log 10 base 10, I have log 10 6x minus 4 over 2 equals log 10 base 10. We know that log 10 base 10 is 1, so we have not committed any crime. So moving forward, when you have your logarithm to be the same, you cancel your log and equate the values. So we have 6x minus 4 over 2 equals 10. Evaluating, we have, let me rub this. We have 6x minus 4 over 2 equals 10. You cross multiply. You know how to cross multiply. We have 6x minus 4 equals 2 times 10. 6x minus 4, 2 times 10 will give you what? 20. Now collecting like terms, we have 6x equals 20. Taking minus 4 to the other side, we have plus 4. So 6x equals 20 plus 4, we give 24. Remember that we are finding the value of x. We are looking for the value of x. So we need to make x as a subject, as mean x should be standing alone. So dividing both sides by the coefficient of x, which is 6. So divide both sides by 6. 6, we cancel 6. Now we have our x standing alone, which 6 in 24 will give 4. So finally, we have the value of x to be 4. Question number 4. Evaluate log 9 base 3 minus log 8 base 2 all over log 9 base 3 again. So you're given this question, you're asked to evaluate. So we try to simplify. Solution. Simplifying this logarithm, breaking it down to simpler form, we can take this log 9 to be in base 3. That is, we have log 9 as 3 raised to the power of 2. And we can simplify this 8 to be in base 2. That is, log 2 raised to the power of 3 in base 2, all divided by log 9 can be simplified as log 3 raised to the power of 2 in base 3. So like I said, at one of the rules of logarithm, the power rule, which is when you have a power, you bring it down to multiply the log. So applying that here, if I bring down this 2, I have 2 log 3 base 3 minus, bringing down this 3 log 2 base 2 all over, then bringing down this 2 also, 2 log 3 base 3. So looking at it, we know that we can also apply the rule of same base. When the logarithm and the base are the same, it equals to 1. So applying that here, this gives me 2 times log 3 base 3 is 1 minus your 3 times log 2 to base 2 is 1 all over, I have 2 times log 3 to base 3 is also 1. So simplifying further, 2 times 1 will give you 2 minus 3 times 1, 3 all over 2 times 1, 2. So what is 2 minus 3? It will give minus 1 all over 2. So finally our answer is minus half. Question number 5. We have log x minus 1 base 10 plus log x plus 2 base 10 equals 1. So having this question, we can see that this is addition. And like I said, as part of the logarithm rule, we have the multiplication law is simplified as addition. That's if you have, say for example, you have p times q as your log p times q, we have log p plus log q. So this rule was applied here because looking at this addition here, we can as well say this log multiplied with this log was what was simplified as this log x minus 1 plus log x plus 2. So let's do that. We have log base 10 x minus 1 times x plus 2 equals 1. You have a bracket. Opening up your bracket, we have log base 10. This we multiply x plus 2 minus 1, we multiply x plus 2 again, all equals 1. So we have log base 10, x times x, x squared, x times 2, 2x, minus 1 times x, minus 1 times 2, minus 2, all equals to 1. So simplifying further, we have log base 10, x squared plus 2x minus x we give plus x minus 2 all equals 1. Now before we solve further, we'll try to, this one is not in logarithm, so we have to simplify it to be in the same log. Okay, now we have to make this one to be in logarithm as well. You can either do that or use the changing from logarithm to exponential function. If you use that method, it means the base of this log, we come here and put this one as the exponent. So doing that, applying that here, so we have x squared plus x minus 2 equals 10 raised to the power 1. So it means our logarithm is gone. So having this, what is 10 raised to the power 1? X squared plus x minus 2. 10 raised to the power 1 will still give you 10. We can bring this to the other side, which is x squared plus x minus 2 minus 10 equals 0. We have x squared plus x minus 2 minus 10 we give minus 12, all equals to 0. Looking at this equation, it's a quadratic equation. So when you have a quadratic equation, we have different methods of solving. Either you use your completing the square, the formula method, the factorization method, and graphical method. But because of time, factorization method is very fast. So with this, I'm going to be using factorization method to solve. So how do we factorize this? You pick the first and the last term, which is, I have minus 12x. You multiply the two of them and get the factors of minus 12. The factors of minus 12 you are looking for are the ones that when you multiply, it should give you minus 12. And when you add or subtract, it should give you plus 1. So what are the two factors of this 12? If I use 4 and 3, I will have to make sure that I put a sign that will fit in. Because if I use a wrong sign and it's not giving me these values, it means I cannot use those factors. So if I have plus 4 and I have minus 3, plus 4 times minus 3 should give you minus 12, right? And plus 4 minus 3 will give you plus 1. So I think these two factors are perfect. So substituting these factors here, we have x squared plus 4x minus 3x minus 12 equals 0. So we factor out what is common here. X plus 4. What is common here is minus 3. We are left with x plus 4 equals to 0. You realize that this bracket, they are the same. So you pick one of the factor here, x plus 4. And the numbers that are outside the bracket, you bring them together as x minus 3 equals 0. So equating them one by one, x plus 4 equals to 0. X minus 3 equals to 0. From here, our x will be equals to minus 4. And from here, our x will be taking minus 3 to the other side, will be equals to 3. So the value of x is either minus 4 or plus 3. And this gives to the final answer. On this note, we have come to the end of today's class. Hope you enjoyed the lesson. See you in my next class. God bless.
That's the much we can take today on the program. Join us next time for another educating session.